Hi, this is Alex from devstories.eu. Prompt Flow, the Complete Guide, Episode 10 of 14. When a language model returns a hallucinated garbage answer, how do you know if the model itself failed or if your prompt formatting logic had a bug? You can scatter print statements throughout your application, but that becomes impossible to maintain as your application grows. Tracing LLM interactions fixes this by capturing the exact context of every execution. Tracing turns a black box LLM application into a transparent, debuggable sequence of events. It records precisely what data goes into a function, what comes out, and how long the execution takes. In this ecosystem, you handle this with the promptflow-tracing package. The data it generates is based on the OpenTelemetry specification, meaning your execution records follow an industry-standard format for observability. To capture the baseline interactions with a model, you use a function called startTrace. If you call this function at the very beginning of your Python script, PromptFlow automatically instruments supported model clients. For example, if you are using the standard OpenAI Python package, you do not need to modify your API calls at all. The tracer quietly intercepts the interaction, logging the system message, the user prompt, the specific model parameters, and the final response string. Capturing the API call is only half the battle. The logic leading up to that call is usually where bugs hide. To trace your own application logic, you apply the trace decorator to your custom functions. Consider a function named math-to-code. This function takes a user describing a math problem, fetches necessary context, constructs a prompt, and finally requests Python code from GPT-4. By placing the trace decorator directly above the math-to-code function definition, you tell PromptFlow to record every execution of this specific block of logic. It will log the user input string, the final returned code, and the latency of the entire operation. Because you also ran startTrace at the top of your file, the system understands the relationship between your code and the model call. It builds a hierarchical record. Your math-to-code function becomes the parent span, and the internal OpenAI call becomes a child span nested inside it. You view this hierarchy using the local trace UI. When you run a traced script, PromptFlow starts a local server that you can open in your web browser. This interface gives you a visual timeline of your application flow. You can select the parent math-to-code span to verify the arguments it received. Then you can select the child OpenAI span to inspect the exact raw prompt string that was successfully sent to the model over the network. If your context assembly logic missed a variable, you will see the empty space in the raw prompt immediately. The real power of tracing is not just collecting execution logs, but definitively proving what happened at the exact boundary between your application code and the external model. That is all for this one. Thanks for listening, and keep building.